In this video, I like to show you how to isolate concentric rings of dissemination areas based on a central point. For example, I like to use the city of Toronto as an example, and that center point from which I can draw concentric rings, it's Queen's Park. So what I have here is already an opened project for QGIS, and I already imported a few files ready to use. Number one, you can see that I have the DA boundary files. So this is 2021 dissemination area cartographic boundary file. And the second thing I've done is I've added Google Map as an underlying layer just to visualize, to get started, to see the orientation of where we are dealing with. The third file that I have is the Toronto CMA 2021 DA data, and that is the census variables that I have downloaded from CHAS. If I open the right click at the file and then open attribute table, you can see that this is actually for the entire Ontario. All the DAUIDs and a whole bunch of variables I have downloaded from 2021 census. What I have done is I already joined this table, Toronto CMA 2021 DA data, with the DA boundary file. Using properties and the join and click the plus and add that table in. So once you have done this, check open attribute table for the boundary map. You will see the attribute table already has all the variables attached to the Toronto City DA boundary file based on the DA data file. The third file that I have opened or created is Queen's Park location. You can see that's right there in the middle of the map. I've went to Google and searched for Queen's Park location, extract the latitude and longitude, put it into a CSV file, then do a layer, add the limited text layer, and pull it into QGIS. I have other videos that have shown how to do this with Starbucks location specifically. But here, using Queen's Park, this is the center from which I'm going to draw concentric rings and isolate just the DAs within a particular ring. So let me turn off Google Map so that it's a little clearer now. The first ring that I want to create is within 500 meters around Queen's Park. You can see the red dot, it's our center. So to do so, the first thing, actually, easiest thing to do is make things faster. It's go to Toronto CSD DA, the boundary map, right click, go to properties. And if you come to this tool, the settings, you can see that data source, geometry, here you might have it shown that the spatial index does not exist. If it does not exist, click that. It will create a spatial index for each polygon so that later on when we are searching through the map behind the scene, QGIS will be a lot faster. So if you haven't done so, click spatial index, create, and then apply and okay. And I have already created the spatial index, so it says it exists. Now then what you want to do is go to this icon, click the arrow down, select within distance. I want to select features from the DA boundary file by comparing with my Queen's Park location, where I want to include all the DAs within 500 meters surrounding Queen's Park. Run. If you do not have a spatial index for the boundary map, it will take a little longer. Once you have the spatial index, it's just in split seconds. Once you have done it, close it, and you can see that within 500 meters, the DAs are already selected. Right-click at the Toronto DA map, export, save selected features, those that are selected within 500 meters. Save it as a comma-separated value file. Choose a particular location where you want to put it. Suppose I want to put it in this folder, 500 meters. Leave it as CSV, save. Everything else is fine. Okay. And you will discover that in the directory, let me go there. Your 500 meters CSV file openable in Excel, it's right there. Now, next, I want to select just between 500 meters and 1 kilometer, excluding those within 500 meters. So to do so, what I would do is delete these DAs already selected from my DA map. So click that pencil icon to allow me to edit this layer. Sorry, I need to select the Toronto CSD DA map first, then click the pencil icon. And you will see that those polygons that were previously selected are now highlighted. And now go to Edit. Select, here, Delete Selected. There you go. Delete 17 features. Now that becomes a donut in the sense that those that were previously selected were no longer available on the current map. So repeat the procedure we had earlier on. Click the Select Within Distance. I want to choose the CSD DA boundary file by comparing to Queen's Park, but now this time it's within 1,000 meters, or you can say 1 kilometer. You can choose the different units here. Let's say I stick with 1,000 in terms of meters and run. Okay, close. And you can see that these are the ones that are selected. And then right-click, export, select Save Selected Features as a comma-separated value file. Now this time, let me say it's 1,000 meters. Save and OK. Suppose I want to create a ring that is between 1 kilometer to 2 kilometers, excluding those less than 1 kilometer. So what I would do is select Toronto CSD DA file, edit, and delete selected features. And there are 49 DAs within the previous ring. Delete them. So now the hole within the donut is bigger, and repeat the procedure. Select within distance and comparing with Queen's Park, and this time I want 2 kilometer. Run. Close. And these are all the DAs between 1,000 and 2 kilometer. And right-click, export, save selected features as comma-separated value, and I want to call it 2,000 meter or 2 kilometer. Save, OK. Repeat the procedure. Edit, select Toronto first. Edit, delete selected features. I have 144 in my last ring. Delete them. Now keep creating and exporting and deleting. And now we have created concentric rings of DAs around Queen's Park. So now go back to the Excel file. It's really 500 meters, 1,000 meters, and 2,000 kilometer. If you click open one of these Excel worksheet, let's say read only because my QGIS is still using it, you can see that all the variables that I originally attached or joined to the boundary file are kept within the same CSV file. Then you can do the summaries and create a table for each ring for the variables of interest.